All right, here we go. We are showing you step-by-step solutions from IBSL2 Paper 1. Okay, so here we go. Let f of x equals 7 minus 2x and g of x equals x plus 3, g of f of x. So for A, I like to think of that as g of f of x. And all we're going to do is replace, since I'm finding g of f of x, I'm replacing f of x with what it equals, so that's 7 minus 2x. Okay, and g of x equals x plus 3. So I'm going to replace this x with 7 minus 2x, so this becomes 7 minus 2x plus 3. And remember, this came from g of x x plus 3, and we just replaced 7 minus x with 7 minus 2x. And we simplify that and we get 10 minus 2x. So that's the answer to that. B, write down g negative 1 of x. Well, for g of x, I'm going to rewrite that as y equals x plus 3. So the inverse, that's what that notation represents, I would find by swapping out x equals y plus 3. So that means y would equal x minus 3. So g negative 1 of x, or the inverse of g of x, is equal to x minus 3. No big whoop. And so now I have to find f of, I always like to rewrite this because it's kind of confusing, g of, or the inverse of g of 5. Okay? Well, I have the inverse of g of x right here. So g negative 1, or the inverse of g of 5, is equal to 5 minus 3, which is equal to 2. So that means I am going to replace g negative 1 of 5 with what it equals 2. So this becomes f of 2. And that just becomes 7 minus 2 times 2 from f of x up here, which is equal to 7 minus 4, which is equal to 3. Cool. Next problem, number 2. A line L passes through this point and is parallel to this vector with a starting point of negative 2, 1, 5 plus multiplied by some scalar s 1, 3, negative 2. Write down a vector L in the form R equals A plus TB. All right, well, R, well, we know here a line passes through A, 1, negative 1, and 2. So that's what I'm going to use as my A, which is any point on the vector. So that's going to be 1, negative 1, 2, plus T times 1, 3, negative 2. So that's no big deal at all. Okay, all I did is replace this with a point I know that is on L, and I can say T times 1, 3, negative 2. It's going to be parallel times that, because this part of it is giving the direction. This part of the vector right here gives the direction. Okay. The line L passes through point P when T equals 2. Okay. Find OP. Okay. Well, that would give me, so let's do BI, right, like this. 1, negative 1, 2, plus 2 times 1, 3, negative 2. I mean, they told me right here that t equals 2, so all I'm doing is replacing t with 2. So that would equal, let's see, 1, negative 1, 2, plus 2, 6, negative 4. All I did is I took 2 and multiplied by each of those. And that gives me 3, 5, negative 2. Okay? So remember, in vector world, O stands for the origin. So vector OP is simply equal to 3, 5, negative 2. No big whoop. There we go. And then to find, remember this stands for the magnitude of OP. And if you forget the formula for magnitude, I thought I had all my formula sheets up, but I guess I don't. Let's go to vectors on our formula sheet. There we go, magnitude of a vector. I'll just take a quick picture of that. Sorry I didn't have it earlier. Okay, and there it is. So maybe I forgot how to find the magnitude of a vector. It's just the square root of all its components. Okay, so the magnitude of OP is equal to the square root of the sum of all of its components squared. So 3 squared plus 5 squared plus negative 2 squared equals the square root of 9 plus 25 plus 4, which is equal to the square root of 38. Coolie mama. Okay, onward to number 3. Let's see here, I already have the formula sheet that I'm going to need here, but this is the matrix A, and it says find A negative 1. Well, here we go. That's the inverse of a 2 by 2 matrix. It's equal to 1 over AD minus BC times this. Okay, so this is really just a bunch of plug and chug. If you have to, label this stuff. This is A, this is B, this is C, this is D. So the inverse matrix is going to be equal to 1 over, and look, this is the AD minus BC is just the determinant of the vector, which I know you have done. So that's going to be 2 times 3 is 6, minus negative 1 times negative 4 is 4, times, okay, remember, we just switch these. The A and the D switch, so this becomes 3, and this becomes 2. And then we negate, the B and C don't switch, but we do negate them. So this becomes positive 1 and positive 4 because they are currently negative. Bam. So this becomes 1/2 times 3, 4, 1, 2, which would be equal to the vector 3/2, 2, 1/2, 1, just multiplying everything in here by 1/2. So that is part A. Bam! Okay. Part B. Solve the matrix equation AX equals 4, 6, 2, negative 2. Well, if you recall, let's see, the inverse of a matrix times itself is equal to the identity matrix. And the identity matrix multiplied by anything is equal to the anything. So if I take A negative 1 times A, I'm left with X. And that is fine as long as I take A negative 1 times this. But you have to be careful. With matrix algebra, you have to do things exactly the same way. In other words, matrix A times matrix B does not necessarily equal, or almost all the time, B times A. So you always have to multiply in the same order. So in this case, X is going to equal the inverse matrix, which we found to be 3/2, 2, 1/2, 1, multiplied by 4, 6, to negative 2. Okay? And then you have to remember how to multiply matrices. So I have a 2 by 2 times a 2 by 2. Okay, so I have to get my first component. Okay, and my first component is going to be row 1 times column 1. 3/2 times 4 is 12 over 2 plus 2 times 2 is 4. Then row 1 times column 2 would be 3/2 times 6, so that's going to be 18/2. Let's see, 2 times -2, so that's going to be -4. And then I'll take row 2 times column 1. 1/2 times 4 is 2. 1 times 2 is 2, so 2 plus 2. And then row 2 times column 2, 1/2 times 6 is 3. 1 times -2 is -2, so 3 minus 2. And we simplify that to be, let's see, 6 plus 4 is 10. 9, 18 over 2 is 9 minus 4 is 5. And 2 plus 2 is 4. 3 minus 2 is 1. So the answer is 10, 5, 4, 1. Okay, I'm going to stop and we'll continue on the next video.